Let's begin. Today's October 18th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 5, 8, 18, 19, and 20. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A takes a look at our first digit, the triangle digit, and the Turing machine will let us know whether its value is either an even digit or an odd digit. Criteria card B will take a look at the 3-digit solution, and the Turing machine will let us know how many of those digits are 1. Are there no ones? Is there a single one? Perhaps 2, maybe even all 3 are 1. Criteria card C will take a look at our 3 digits, triangle, square, and circle, and we'll add them up, and the Turing machine will let us know whether the sum total is an even quantity or an odd quantity. Criteria card D will take a look at the first 2 digits, triangle and square, add them up, and compare it to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E, again, we'll take a look at the 3-digit solution, but this time it'll let us know a little bit about its structure. Specifically, it can inform us whether there are no repetitions in our code, as in the example 125, or it can let us know that there's a double number, as in the example 112, or it can even let us know whether it's a triple number, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I'd like to test is criteria card A. So the Turing machine approves of my choice for triangle. I did pick an odd 3. So since the Turing machine agrees with it, we can say that the first digit, that triangle digit, is in fact an odd digit. So let's go ahead and type that up in our notes in section A. And we'll say that triangle is an odd digit. And since it is odd, that means we can actually cross out both evens. So let's go ahead and cross out 2 and 4. So the next thing I think I'd like to test is criteria card C. Okay, so again, the Turing machine does approve of my proposal. Notice that in this case, criteria card C, we're adding up all 3 digits. So let's go ahead and add up the digits in my proposal. And that is 3 plus 1 is 4. 4 plus 4 is 8. So the Turing machine agrees that the solution should have a sum total that is an even quantity. So let's go ahead and type that up in our notes in section C. And that is, again, that triangle plus square plus circle should be an even quantity. And so what can we say about that? Well, we've already established that triangle's odd. And if we want the sum total to be even, that means that one of the digits among square or circle has to be an odd, so that when you add the odd triangle to, again, an odd, that's either square or circle, that gives us an even quantity, and then the other digit must be then even. So that means we're looking for, a solution that has 2 odds and a single even. And obviously triangle is odd, That means that one square or circle is odd and the other is even. So a solution that has two odds and a single even. So we could test criteria card E to see if those odds are paired up. So let's go ahead and test criteria card E. Okay, so again, the Turing Machine does approve of my proposal. Notice that I have all distinct digits. So, in fact, there are no repetitions in our solution. So let's go ahead and type that up in section E. So we'll say that the solution has no repetitions. Okay, and well, that does it for this round. We have concluded, we've completed our 3 Turing tests, and so now we're going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test the number of ones, criteria card B, in our solution. And we did not test criteria card D that takes the sum of the first 2 digits and compares it to 6. And it really comes down to those 2 criteria cards. So the first thing that I'll say is we got all 3 check marks. So is it possible that our solution is 314? Well, even though the first 2 digits might add up to be less than 6, I don't see anything in the criteria cards that would basically allow us to guess between, it would seem that circle's even for circle to be 2 or 4. I just don't see that. So no, I don't believe that the solution can be 314. So it does need to change. And again, even though we do have an odd and even in triangle and circle, I'm not sure about the ordering or which one, where the even goes. So that said, could we have a sum of 6 in triangle and square? Well, again, I don't see how the sum could actually be equal to 6, because even though we do have a card that tells us, yeah, there's a single 1, there's nothing in the criteria cards that would let us pick between 1 and 5, like which one goes where. I don't see that. And again, that would mean that circle would be the even digit. Well, that said, since we're looking at all unique solutions, I don't think that square would actually be odd, because the only way you can get a sum of 6 is if you had 1 and 5. And again, I don't see any way to even order the 2 odds, let alone what circle would be. So I don't think that the sum is going to be 6. And because we are talking about unique digits, well, I guess technically we still could have, well, I think we just established earlier that I don't think the sum could be, I guess, even and less than 6, because that would be 1 and 3, no duplicates. And yeah, I don't think the sum is going to be even, so I really do think it's going to be odd, even, odd. Now the question is, what would that mean? So I wonder if criteria card B, the number of ones, if that fails, if there are no ones, we know for a fact that you would have to use 3 and 5 somewhere. And so let's go along with that premise where maybe there are no ones and we're dealing with a 5 or a 3. Could we could have a sum that's less in 3 and 2, but 3, 4 would be greater, and 5, 2 and 5, 4 would be greater. So maybe I'm trying to see how can we force, the values of either square or circle. So it could be something like maybe 3, 2, 5. Would that be sufficient? And there are no ones, and you want the sum to be smaller. So a triangle could not be a 5. It would be a 3. And yeah, so that would force it to be a 2. And then you'd have to have another odd, and that would be 5 because there are no ones. Yeah, let's go with 3, 2, 5 and see where that takes us. Okay. All right, so now the question is, could we deduce one of these possibilities? If there are no ones, perhaps if it was 5, all those would be greater. So maybe we can deduce that the sum would have to be less than 6 if we can confirm that there are no ones. Is that right? Yeah, because everything would be greater with that 5. It'd be 2. Or what if we tested the sum? Well, yeah, I think I'm just going to have to test both of them. But first, let's go ahead and test criteria card B. Yeah, okay, so it's true that there are no ones in our solution. So let's go ahead and type that up in our notes. And we'll say that the solution has no 1 digit. And of course, if there are no 1 digits, we can cross them all out. Okay, and I really do believe that the sum must be less than 6, because if it's greater, I think there are just way too many possibilities. But yeah, let's go ahead and test criteria card D. And yeah, so the sum is less than 6. I just wasn't too sure about the mechanics of how to, I guess, prove or argue that, yeah, that's likely what should be true, that the sum of triangle and square should be less than 6. I was concerned about having to maybe list too many ambiguous solutions. Okay, so yeah, if the sum is less than 6, then obviously triangle cannot be a 5, because 5 plus at a minimum of 2 is already greater than. So yeah, so that forces triangle to be a 3, and there are no duplicates, so you can't add triangle 3 with 3, 4, or 5. So yeah, so you're forced to have square be 2. So it can't be 3, 4, or 5. And so, and if we want the sum total to be even, so far we have an odd sum, 3 and 2 is 5. You have to add another odd to that odd, sum that's odd, to end up with an all even sum. So, and because you can't have duplicates, so you can't have an even, and you can't have a 3 or a 4. So yeah, you're forced to have a 5. And that's what our second round proposal was, 325. Okay, so while my form here starts typing up that solution, let's verify. So again, we got 325, there it is. And so let's quickly verify if everything works. Is the first digit odd? It is. The solution should have no ones, and that's true. The sum total is even. Yes, it's a sum of 10. The sum of the first two is less than 6. It is, that's 5. And no repetitions. Yeah, it looks like we got it right. And, you know, knowing that you have all the check marks above, and if you didn't alter those responses from the first round, yeah, 325 should work. So let's go verify 325 as our solution. So 325. Fantastic. Well, how did we do versus the Turing machine? Well, as I recall, I think we had 5 criteria cards and we did do the 5 tests. So at best, you know, well, not at best, but at worst, technically, we tied. And, well, we did everything. We did ACE in the first round and the remaining 2 in the second round, and we got all checks. I don't know if that's the first time I've gone all checks before, but it does not occur that often. So ACE in the first round and then BD in the second. And yeah, we beat him by 1 question. So like I said, I was a little hopeful that I could deduce, but it seemed that it would just take too much of an effort, and I don't know if I would have felt confident. But still, we still beat the machine by 1 question. And like I said, very unusual, but we got all check marks. Well, how did you do it? What criteria cards did you choose in the first round? And did you see anything interesting? You can always share those ideas in the comment section. If you liked the video, give it a thumbs up so that more people can find the video. And of course, don't forget to hit subscribe so you don't miss out on any future videos. Well, until next time, have a great one.